Welcome. This is the second of the calculus review lectures, and I want to just go over a couple of problems today. So the first one is to evaluate the limit as x goes to 2 of x to the fourth minus 3x squared plus 5. And so the book gives three answers. A is 0, B is 2, C is 9, and D does not exist. Now for this problem, it's actually not too bad. It's clear by looking at it that the limit exists and you just plug in x equals 2. So you could evaluate it that way. If you also do a little bit of thinking and just try to reason, you notice one, limit exists, so not D. And then two, when you plug in x equals 2, the x to the fourth should be the 3x squared. So it's probably positive and at least 5. So that means it should be C. You could also note it is odd as x to the fourth and 3x squared are even, and 5 is odd. Or of course, you could just do 2 to the fourth minus 3 times 2 squared plus 5. And a nice way of doing the algebra is we notice that 2 squared divides the first two terms. So we can write as 2 squared minus 3 plus 5. That's just 4 plus 5 equals 9. And again, whenever you can do little tricks to save time, that's great. So for the other problems in the chapter review, for the most part, they were not too bad. One of the ones that I found a little bit interesting was number 3. So evaluate the limit as x goes to 7 of x cubed minus 3x minus 28 over x to the x squared, sorry, the top is x squared, minus 5x minus 14. And whenever you see a problem like this, the first hope is to just try to plug in the value for x. So the numerator would be 7 squared minus 3 times 7 minus 28. That's 49 minus 21 minus 20, that's 0. The denominator is going to be 7 squared minus 5 times 7 minus 14, which is also 0. So because it's 0 over 0, we can't do the limit of a quotient is the quotient of the limits. So there's a couple of ways to approach this. One is you could use L'Hopital. And then this is the same as the limit as x goes to 7 of 2x minus 3 over 2x minus 5. This is no longer 0 over 0, so this would just be 2 times 7 minus 3 over 2 times 7 minus 5. 14 minus 3 is 11. 14 minus 5 is 9. So that's one way to solve it. Another is to factor. And because we have x going to 7, we know x minus 7 is a root of both. So it's going to be the limit as x goes to 7. So the first, if x minus 7 has to be a factor, and we've got to get 28 with a negative 3, it's going to be x plus 4. And the second for down below would be x minus 7. And since we need to get a negative 5, it's going to be kind of 14. It's going to be x plus 2. So now the x minus 7's cancel. And this is just going to be the limit as x goes to 7 of x plus 4 over x plus 2, which again is 11/9. So if you know L'Hopital's rule, that's a much faster way of evaluating something like this. Another one in the chapter review, which was a little bit interesting, was number 5. So we want to find the limit as x goes to 0 of 4 sine of 3x over 2 tangent of 5x. Well, the first thing is to notice that we have the 4 over 2, that just becomes a 2 that we can pull out. So it's just 2 limit as x goes to 0 of the sine of 3x over the tangent of 5x. And so as x goes to 0, we have 0 over 0. So numerator as x goes to 0 is 0, as is denominator. So one possibility is you could use L'Hopital. You would have to remember what the derivative of tangent is, and you would have to use either the chain rule or the multiple rule. You could use, to make things a little bit easier, that the tangent of 5x is the sine of 5x over the cosine of 5x. And so now we have the limit, or I guess 2 times the limit, as x goes to 0, of the sine of 3x over the sine of 5x times the cosine of 5x. Well, as x goes to 0, the cosine of 5x goes to 1. So this is just going to be 2 limit as x goes to 0 of the sine of 3x over the sine of 5x. And we've done this before. This is just L'Hopital's rule. And it's the limit as x goes to 0. The sine of 3x derivative of sine is cosine. So you have cosine of 3x times 3. You remember the chain rule, we have to take the derivative of the 3x, and the bottom will be the cosine of 5x times 5. So it's just going to be 6/5. And so the last one to just briefly talk about from the practice problems is number 6, the limit as x goes to 5 of 11 over x squared minus 5. I'm sorry, minus 25. So whenever you have a denominator, you should be immediately concerned where's the denominator 0. So where is denominator 0? So we need x squared minus 25 equals 0. So x equals 5 or negative 5. So x equals 5 is one of the troublesome points. And so here, the limit does not exist. And if we plot this function, we see what's going on. So here's 5. We see that as x goes to infinity, the function is going to go to 0. And as x goes to 5 from above, the denominator is a little bit greater than 0. So it's going to be going off to plus infinity. So it's going to look something like this. And conversely, when x is a little bit less than 5, it's going to look something like this. And so this is why the limit doesn't exist, because if we take the limit as x goes to 5 from above of 11 over x squared minus 25, we get positive infinity. If we take the limit as x goes to 5 from below of 11 over x squared minus 25, we would get negative infinity. Now, if we instead looked at the limit as x goes to 5 of 11 over x squared minus 25 squared, then we could say that that would be infinity, because that would have the same value in both cases. Okay, so now moving to the next section, which is going to be derivatives. And so this is problem set 3. And now there's a bunch of problems here that we can look at. And so the first one is to find f prime of x at x equals 3 when f of x equals 5x. So the way all these problems work is you first find the derivative and then you substitute. So for this one, f prime of x is just going to be 5. So f prime of 3 is just going to be 5. Doesn't matter what our input is. It's always going to be 5. So a lot of these problems are going to be very similar. So for number 10, we now have f of x equals 2 square roots of x at x equals 9. And so the way I like to solve problems like this is I'll write f of x as 2x to the 1/2. And now I'm going to use the power rule. If I have x to the r, and I take the derivative, it's r x to the r minus 1. So f prime of x is going to be 2 times 1/2 x to the 1/2 minus 1, which is just x to the minus 1/2. So f prime of 9 is going to be 9 to the minus 1/2. Well, 9 is 3 squared to the minus 1/2. That's just 3 to the negative 1, or 1/3. Another interesting problem, which I didn't give my students when I was assigning this, but I probably should have, is number 11, which is f of x is 5 square root of 2x at x equals 8. So again, there's a lot of ways you could do this. We could do f prime of x is 5 times the derivative of 2x to the 1/2. That'd be 5. Now, the derivative of 2x to the 1/2 would become 2x, I'm sorry, 1/2 2x to the 1/2 minus 1 times the derivative of 2x. So that would be 5 1/2 2x to the minus 1/2. And then the derivative of 2x is going to be 2. And so this is going to be 5 times 2x to the minus 1/2. And then we just plug in x equals 8. And we get f prime of 8 is going to be 5 times 2 times 8 to the minus 1/2. That's 5 times 16 to the minus 1/2. Well, 16 is just 2 to the 4th, so it's 5 times 2 to the 4th to the minus 1/2, which is 5 times 2 to the minus 2, or 5/4. Another way to do this problem is to say f of x is just 5 square roots of 2 times x to the 1/2, and just put all the constants together. And now if we do that, we get f prime of x is 5 root 2 times, now we do x to the 1/2, its derivative is going to be 1/2 x to the minus 1/2. So f prime of 8 is 5 root 2 times 1/2 8 to the negative 1/2. Well, this is 5 times 2 to the 1/2, 2 to the negative 1. 8 is 2 cubed, so that's 2 to the negative 3/2. And 1/2 minus 1 minus 3/2 is the same as 2 to the negative 4/2, which is just 1/4. And so we again get 5/4. So again, depending on which number you're going to do, sometimes one way is a little bit easier to do the algebra than another. Okay, the other two problems from this was number 17, was number 12 and number 16. So for number 12, we want f of x equals the sine of x at x equals pi thirds. So for this, we very quickly get the derivative of sine is cosine of x. So f prime of pi thirds is cosine of pi thirds, which is 1/2. So we have to remember what is the cosine of 1/2. And for problems like this, I always like to draw the unit circle, which hopefully this will look something like the unit circle. And so we know a couple of points. So here is the point 1, 0 that corresponds to an angle of 0. Here's the point 0, 1, which corresponds to an angle of 90 or pi halves. We know the 45-degree line is root 2 over 2, root 2 over 2. And then we also have 30 degrees like this, and then the 60 degrees, or again, 30 degrees this way. And this point over here is root 3 over 2, 1/2, and the other one over here would be 1/2 root 3 over 2. And if you look at this point at 30 degrees, it's clear that the x component is larger than the y component. That's how you remember which way it is. This comes from knowing an equilateral triangle. So if I give you an equilateral triangle, 1, 1, 1, if we now cut it in half, actually, I guess let's use another color. We have so many colors. If we cut it in half, each part of the base is 1/2, and then by Pythagoras, this is root 3 over 2. This angle here is 60 because it's an equilateral triangle, so these two angles up here must be 30. So this gives us the cosine of 30 degrees is going to be root 3 over 2, and the sine of 30 degrees is going to be 1/2. And of course, this is the same as the cosine of pi over 6, and this would be the same as the sine of pi over 6. And then 60 degrees would just be twice that. The last one from this section was the general formula for just the derivative of a quadratic. And so the final set I wanted to do today is problem set 4. And this is going to be on special functions. So looking at these problems, the first one that I wanted to discuss was problem number 1. So for problem number 1, we have 4x squared plus 1 squared. So there's a lot of different ways to do this. The first way is the power rule. So the derivative is 2 4x squared plus 1 to the 2 minus 1 times the derivative of 4x squared plus 1. So that's going to be 2 4x squared plus 1 to the first power, and the derivative of 4x squared is just going to be 8x. So we just get 16x 4x squared plus 1. So that's one way to solve it. Another way to solve it is the product. Is we can write this as 4x squared plus 1 times 4x squared plus 1. And if we write that as f of x times g of x, the derivative is f prime of x g of x plus f of x g prime of x. So here, it's going to be the first derivative is f prime, so it's going to be 8x from what we just said earlier, times 4x squared plus 1 plus 4x squared plus 1 times 8x. And not surprisingly, when you add that up, you get 16x squared. So 16x 4x squared plus 1. And another way is to simplify. We could just multiply everything out. Our function is 16x to the 4th plus 8x squared plus 1. So the derivative is going to be 16 times 4, 6 times 4 is 24, 64x cubed plus 16x. And if you factor, well, we see 16x divides everything, 16x, and then we'll be left with 4x squared plus 1. And not surprisingly, all the different approaches give the same answer, but sometimes one way is a better way of doing algebra than another. Next problem I signed was derivative of 18x cubed plus 12x plus 11. This is a straightforward polynomial. I'm going to move on and talk about number 8, which is a little bit more interesting. And so for problem number 8, we have f of x is equal to negative 8x to the minus 8 plus 12 square root of x. And again, when I do problems like this, I like to rewrite them in a nice way. Negative 8x to the negative 8 plus 12x to the 1/2. And we see that the derivative of the first rule we use is the sum rule. So, writing it very slowly, it's the derivative of the first piece plus the derivative of the second piece. We can then use the constant rules and pull out the negative 8 and the 12. And I need the derivative of x to the negative 8. And I need the derivative of x to the 1/2. Well, what's the derivative of x to the negative 8? This is the power rule. So it's going to be negative 8 x to the negative 9. Because remember, we decrease the power by 1. Plus 12 times 1/2 x to the 1/2 minus 1 is negative 1/2. So it'd be 64 x to the negative 9 plus 6x to the minus 1/2. So the next one is number 10, which is, again, a similar number. It's x to the negative 5 plus 1 over x to the 8. And so 1 over x to the 8, you would just write that as x to the negative 8 and use a similar rule. For number 11, this is similar to one we just did a little bit earlier. And so number 11 is going to be f of x is 6x squared plus 3 times 12x minus 4. And again, there's two very natural ways to do this. The first is the product rule. And so it's going to be 6x squared plus 3 derivative times 12x minus 4 plus 6x squared plus 3 times 12x minus 4. Well, the derivative of 6x squared plus 3 is going to be 6 times 2x. Multiply that by 12x minus 4. And then for the second one, it's 6x squared plus 3. And the derivative of 12x minus 4 is just going to be 12. And then we can expand and simplify. If you want, a good way to do problems like this is to say f of x equals a of x, b of x, and then just write down what everything is. A of x is 6x squared plus 3. B of x is 12x minus 4. A prime of x is 6 times 2x. B prime of x is 12. F prime of x is a prime of x, b of x, plus a of x, b prime of x. And now that we have everything here, we just substitute, and we'll get 6 times 2x times 12x minus 4 plus 6x squared plus 3 times b prime of x, which is 12. And when you go slowly like this and put in all the steps, you're much less likely to make a mistake. Another solution is to expand and say f of x, if I expand, is going to be 72x cubed. And then I'm going to have a minus 24x squared. I'll have a plus 36x, and then a minus 12. And notice that this is going to be much easier to find the derivative. I don't have to use the product rule. And then in terms of simplifying, I'm not going to have to bother doing any simplifications later. All right, the last one, number 19, is a little bit similar. So for number 19, we have f of x equals x times 2x plus 7 times x minus 2. And so the first thing is we could try to do a triple product. And so imagine we have a of x, b of x, c of x. And what I'm going to do is I'm going to group the first two together. And I'm going to take the derivative of this whole expression. Well, by the product rule for what we have, we know that this is going to be the derivative of my function a of x, b of x. So we need the derivative of that piece times c of x plus, and now we'll have the a of x, b of x, and now we have multiplied by c prime. And now we can use the product rule on a of x, b of x prime, and that will become a prime of x, b of x, plus a of x, b prime of x. And then we multiply that all by c of x, and add to that the other term, a of x, b of x, c prime of x. So we notice there's three terms. The first term is going to be a prime of x, b of x, c of x. The next term is a of x, b prime of x, c of x. And the last term is a of x, b of x, c prime of x. Oh, so this is a really nice generalization of the product rule. So we might conjecture that if we have, f1 of x, f2 of x, all the way up to fn of x, and we want its derivative, it's going to be f1 prime of x, f2 of x, dot, 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 fn of x, plus f1 of x, f2 prime of x, f3 of x, dot, 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 fn of x, plus, dot, 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 plus, dot, 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 plus f1 of x, f2 of x, dot, 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 fn minus 1 of x, fn prime of x. So this is the generalization of the product rule. So if you have n functions multiplied together, the product rule will have n terms. And what you'll do is in each term, you have exactly one of the functions having its derivative. Now, for this particular problem, we could do that, and we could go through the algebra, or again, we could expand. And if we expand, we notice f of x is going to be x, I'll multiply the 2x plus 7 times the x minus 2 first, so it'll become 2x squared plus 7x minus 4x, so it's going to be plus 3x minus 14, or 2x cubed plus 3x squared minus 14x. And we see that this is a much easier solution. This is going to lead to a much easier way to find the solution than the other. So this is a quick discussion of the problems from these other sections. Have a great day.